All right, welcome back. So last time we sort of did all the setup for us to be able to create the swap chain. So we created some helper functions. We went through choosing the extents and doing a little bit of screen size / like pixel and coordinates dimension conversion stuff, I guess you could call it that. Now we are on to creating the actual swap chain. So now we have everything we need, blah blah blah, runtime, create swap chain function. Let's start with the results of these calls. Okay, awesome. So let's just create a prototype. Right here actually. It's gonna be a void again. It's gonna take in our app struct, like so many other important functions do. And then we're gonna call it from within init, excuse me, init Vulkan. Oh. In here. Great. And then we should put it in just underneath the create logical device, I suppose. Just below here. All right, void that. It takes in our app. Point it to p app. And let's just copy all this JS. So in our query support, swap chain support, it takes our physical device, and I think we wanted to take something else, didn't we, last time? Yeah, VK surface KHR, so the app surface. Scroll a bit, p app surface. Okay, and then for our choose surface format, what does it take in? Oh, it's actually defined below where we're using it, so we should probably move that up. Choose format, takes in the available formats, and let's just put the prototype at the top so we know where it is. Available formats and the format count. Okay, let's throw it next to here. What are you complaining about? Declared here. Oh no, I'm the one declaring it. Oh. I'm just gonna leave that for now. I don't really know what that error is all about. Or warning, something. Okay, so it takes what does it take? These things up here. Yes, on our main app we have this. Wait, do we? No. We might need to make this a global thing. Perhaps. Okay, let's just... No, we don't. It comes from here. It's obviously a bit too early for me in the morning. Format swap chain support, we are sending it the formats. Don't really know why it's complaining. Oh, but also needs the count. Which we have on our struct type, I believe. We do. So, which order? First it takes the count, then it takes the available formats. Okay, so take in the count first. Format count, and then take in that. Wonderful. And then this function takes in the present mode count and the available present modes. Present a mode count and the available modes. And why are you complaining? Implicit declaration of function choose. This is not declaration. Oh, this is telling us this error because we haven't got the prototype above where we're calling it. I'll fix that in a moment. And then finally the choose swap extent it takes in the window and the capabilities. So we need to pass in the p-app window, windom, and the capabilities. Okay. Yep, that looks right. Is it right? Replace derived function, invalid initializer. Type init. There's no init there. Let's come back to this. I don't know what's going on here. Okay. Down. Let's do the function definition or prototype or whatever we want to call it. Let's do it here. Okay, that looks fine. No, it doesn't. It should actually be the same as this. Yep, there you go. That makes sense. And then our other function is this one. Oh, we just did that one. Other function is this one. Okay, so that's the final function definition. And it's being used here. Yep, no more errors like that. Just these ones are, we're not using it. So it's pretty cryptic errors, those, from flight check. Okay, moving on. Aside from these properties, we also have to decide how many images we would like to have in the swap chain. The implementation specifies the minimum number that is required to function. Okay, so we can use capabilities.min image count. However, simply sticking to the minimum means that we may sometimes have to wait on the driver to complete internal operations before we can acquire another image to render to. Therefore, it is recommended to increment it by at least one. Okay, let's do that then. Increment our little thing by one. Whoops. All right, we just have a U32. And there's our image count. Okay. We should also make sure that we do not exceed the maximum number of images while doing this. Where 0 is special value, that means that there is no maximum. Okay, so if swap chain support.capabilities.max image count is more than 0, then we do have a maximum. And our image count is more than the swap chain.capabilities.max image count. So this. Then we shall just set the image count to actually equal the max image count. All right. As is tradition with Vulkan objects, creating the swap chain object requires filling in a large structure. It starts out very familiarly grand. Okay, so we have this VK thing. Let's just create it as is, like so, like we do, like initializing line. Okay, that's going to be our app surface. After specifying which surface the swap chain should be tied to, the details of the swap chain images are specified. All of these fancy things. Let's add those to this list as well. Okay, that's everything in that list. The image array layer specifies the amount of layers each image consists of. This is always one unless you are developing a stereoscopic 3D application. I don't even know what that word means. Let's find out what it means. Stereoscopy, sometimes called stereoscopic images, is a technique used to enable three-dimensional effects. Okay. Interesting. Let's take a look at some of these. Ooh. Looks real nice. Maybe we want to create this. Looks quite similar. Anyway, okay, right, enough random Googling. So the image bit field specifies what kind of operations we'll use the image in the swap chain for. In this tutorial, we're going to render directly to them, which means that they're used as color attachment. It is also possible that you'll render images to a separate image first and perform operations like post-processing. Okay, yeah, it's like applying shaders and all that kind of stuff. In that case, you may use a value like VK image usage transfer BST bit instead and use a memory operation to transfer the rendered image to the swap chain image. Okay, that kind of makes sense. Next, we'll need to specify how to handle swap chain images. Okay, let's just copy this and do our DC++ing of it. All right, let's go. E32, the physical device. So what else does that require? Requires the device and the surface. Okay, so pass it the app and the surface, and it should be happy. We don't have this .value thing, so what is this? This is an array of two items. Okay, we actually just the indices of graphics family. It's already the indices, I believe. Yeah, it's already U32, so that's fine. Okay, I think that's probably correct. Then we're saying indices of graphics family doesn't equal the present family. I think this is what this bit's explaining. But just real quick, I'll update that to be no. Next, we need to specify how to handle the swap chain images that will be used across multiple queue families. That will be the case in our application if the graphics queue family is different from the presentation queue. We'll be drawing on the images in swap chain from the graphics queue and then submitting them to the presentation queue. Okay, there are two ways to handle images that are accessed from multiple queues: sharing mode, exclusive, or sharing mode, concurrent. Whoa. An image is owned by one queue family in exclusive at a time, and the ownership must be explicitly transferred before using it in another queue family. Okay, it's like an ownership kind of thing. This option offers the best performance. But sharing mode concurrent, images can be used across multiple queue families without explicit ownership transfers. All right. If the queue families differ, then we'll be using the concurrent mode in this tutorial to avoid having to deal with ownership chapters. Because these involve some concepts that are better explained at a later time. Concurrent mode requires you to specify in advance between which queue family's ownership will be shared using the queue family index count and pointer to queue family indices parameters. If the graphics queue family and the presentation queue family are the same, which will be the case in most hardware, cool, then we should stick to the exclusive mode because concurrent mode requires you to specify at least two distinct family queues. All right. So I guess that's kind of what we're doing here. If these two are not the same, use concurrent mode and say that we have two queue families, graphics and presentation, and set their mode and give it the pointer to our indices. Otherwise, if they are the same, which they might be for us, probably are. My hardware isn't anything specific, like super special. And then we do image sharing as the exclusive mode, and the index count is 0. All right, and apparently that's optional. Okay, then we go down, we say create info, pre-transform, swap chain support capabilities and current transform. Okay, let's just copy that. We can specify that a certain transform should be applied to images in the swap chain if it is supported transform in capabilities, like a 90-degree clockwise rotation or horizontal flip. To specify that you do not want any transformation, simply specify the current transformation. Okay, so are we doing that? I don't think we're doing any rotations or anything yet. We might do later. The composite alpha field specifies the alpha channel should be used for blending with other windows in the window system. You'll almost always want to simply ignore the alpha channel, hence that. All right, and then these two, the present mode member speaks for itself. Yes, it does. In the clip member, it is set to, if it is set to true, then that means that we don't care about the color and the pixel are obscured. Okay, so stuff's behind something else maybe. For example, because other windows are in front of, okay, so if we have another window on top of our window, don't render the stuff beneath that window, I think. All right, unless you really need that to do some sort of calculations. All right, VK true, or can we just use true, I wonder? That leaves one last field, old swap chain, good old swap chain, which we set to null handle, evidently. With Vulkan, it is possible that your swap chain becomes invalid or unoptimized while your application is running. For example, because the window was resized. Yeah, okay, that makes sense. In that case, the swap chain actually needs to be recreated from scratch, and a reference to the old one must be specified in the field. This is a complex topic that we'll learn more about in the future chapter. For now, we'll assume that we'll never ever create a swap chain. Oh, sorry, we'll only ever create one swap chain. Now add a class member to the store, the VK swap chain KHR object. All right. Wait, whoa, wah. Okay, a class member for us means adding it to our app. VK swap chain KHR. And we'll call it swap chain or swap chain. All right. Creating the swap chain is as simple as calling VK create swap chain KHR. Excellent. Where were we just now? La 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 la. What am I searching there for? Create. What is that thing? Noisy, whatever it is. All right, so there's our error saying we're not using this create info. This is where we use it. Device, likely is going to be a physical device, I would think, but let's just continue. Create info, it's definitely going to be a physical device. Well, definitely, he said. Who knows? And then our P app swap chain. Why don't you like that? Does that need to be a pointer? No. What's these errors all about? Passing argument one of VK for incompatible pointer type. Do you need to be the actual device? Yes. And then that needs to be swap chain. But what is it? Why are you not enjoying? What does that error say? Feel free to tell me if you want. Passing argument 4, VK create swap chain from incompatible pointer type. Is it? Huh. I thought it was right. That was it. VK swap chain KHR. I'm just going to copy and paste it just to make sure. Okay, the app swap chain. Still not really enjoying that. Why are you not enjoying that? Do you want the address of it? Yes, apparently you do want the address of it. All right, so put that inside of an if, and happy days. If that doesn't equal, I'm assuming VK success. Indeed. Then we want to quit and say, yeah, nah, mate, it didn't work. Printf failed to create swap chain. And then exclamation mark to be like, yeah. All right. Cool. The parameters are the logical device, swap chain, creation info, optional custom allocators, and a pointer to the variable to store the handle. Custom allocators. That's probably for our debug message stuff. No surprise there. Cool. This is we do need to do some cleanup. Let's do some cleanup. You should always clean up after yourself. Clean up. Looks like we've got at this very top VK destroy swap chain KHR. Passing in device and the swap chain and nothing. Let's just quickly run things and see what happens. Build and game. Oh, there's a lot of output. What's all this jazz? The value of pcreateinfo image color space does not fall within the begin and end range of the VK color space enumeration tokens and is not an extension at a token. The Vulkan spec states some stuff. What does the Vulkan spec state? Colors. Okay, so our color space is wrong. I hope that loads sometime today. Maybe I can find it in another window that I've opened already. Ha! Yes. It doesn't fall within any of these ranges. Right. Okay, let's start logging out. Is that the only error we've got? Let's just tackle one at a time. Color space. So it comes from the surface format, which comes from here, and comes from our choose function. Right, so something in here isn't quite right. It is a VK color KHR, if I'm not mistaken. Yep. Why? But we cast it. Yes, we had to cast to that because. So that doesn't exist on that struct, on that enum even, not struct. Sorry. Does this one? Is that the same one? It is the same one. That's a format. Why am I think I maybe have made an error here. Let's go back to this real quick. Come back down to there. Going back up. Where are we doing our check for the surface? Percent mode. Surface. So the format is that format that we looked for. Damn, I didn't mean to do that. How did I copy that? I don't remember copying that. Yeah, I've used the wrong thing. It's supposed to be this. That is likely one of the reasons why things aren't working. If we went back and then we remove that cast, it was giving us an error. I should have listened to the IDE. Well, it's not really IDE, but I should listen to Emacs. All right, let's try again. Oh, we still get errors. Let's take a look at what these come out as. So we can see what they actually are. Printf. Whoops. Color space. And it's probably going to be, or is it going to be a string? I don't think it is, because it's an enum, isn't it? Yeah, it's going to be number, integer. All right, check the color space and check the color format. I mean just the format. All right, clear. Validation layer support builder. We've got here color space 1, color space 3, format 0, color space 1 and 3. Okay. Interestingly, does that mean like index 1? And index 3, or does it? I think with the enum that needs to be the number that the enum relates to, I think. So if the response there was 0, it would be the top one. And if it was this number, it would be this. I think maybe that's the problem. Interesting. Let's take a look at how we're creating these formats. I will get there eventually. Oh man, where are we calling it? Calling it here. Passing in our swap chain. So it comes from, let's take a look at where these available formats and colors and stuff get created or found. All right, so within our query swap chain support, let's take a look at these. Here's our formats. First, I'll just take a look at the colors. Although that's on formats. Okay. Let me print this out here. So those details formats, I think I can do formats.format and formats.color space. Formats.color space even. And again, it will be an integer. And then we'll see what actually gets created. Formats.color space. Oh, that's right. Let's just pick the first one. Okay, actually, let's not do that. Let's do that in a for loop. Down here. So for every one of these things that we have, u32, I equal to 0, and we're going to say if I is less than details.format. Details.formats, actually, no, it's format count, right? Yeah, because that's the one that we're updating to match the number of formats that we find. I++. Then let's print out the details.formats at position I color space and format. All right. So let's see what happens. Clear, do it again. Right, format color space 1, 0, format color space, that looks more promising. Does that exist? No. Does that exist? Where could they be coming from? Oh. hang on, now it's a negative. That doesn't seem right. How could it be different? It's got to be a memory address issue. I think it's this. We're creating within this curly brackets block scope. We're creating formats, and we're assigning it to details of formats. We're not making a copy. We're assigning that pointer because it is a pointer really. Because it's the first. It'll be pointing to the first element in the array anyway, so that will be a pointer to that, and then this gets updated, but I think we lose that outside of this scope. Let me just try that. And for this one too. Okay. So yeah, if we run that twice, do we get the same? We don't get any errors. 50, 44, 50, 44. Color space is always 0. Interesting, so it's always this. 50, 44, 50, 44. Yeah, we get that same result. So that at least was an issue. Right, okay, so if we were playing with the wrong things. Okay. So what's the format 44 then? Let's take a look at this struct. BK format 44. These count up. It's 44 and there's 50 sRGB and unorm. Okay, that means nothing to me anyway, but it doesn't matter. Alright, so that's one thing solved. Let's jump back to where we were before. Alright. What else are we printing out that we can remove? Formats.color. Here you go, we can get rid of these two prints. I think that probably works. Hey. Alright. Back to our create function. I think we're on the right track now then. Looks like we are actually creating a swap chain. That's grand. Alright. Back down to where we were. That's the wrong thing. Create swap chain. Here we go. We did all this. We did all this. We did our cleanup. Now we're in the application. I did. And it should use swap chain successfully. Let's just try that once more time with feeling. Yep. Seems to create a swap chain successfully and clean us up with no errors. Great. Retrieving the swap chain images. The swap chain has been created now. Wait, what was this bit? Excuse me, if you get any errors. Failed to find BK instance proc in a layer Steam overlay Vulkan DDL. We have another error. Okay, the swap chain has been created now, so all that remains is to retrieve the handles in the BK images. Okay, what's that? We'll reference these during rendering operations in other chapters, so let's add it to our... I think let's add it to our app. BK image. Alright, create swap chain again. The images, oh, that is the wrong thing. That should be a pointer. All right. So the images were created by the implementation of the swap chain, and they will be automatically cleaned up once the swap chain has been destroyed. Therefore, we don't need to do any additional cleanup code. Sweet. I'm adding the code to retrieve the handles at the end of the create swap chain function right after the vk create swap chain KHR call. Retrieving them is very similar to other times we would retrieve an array of objects from Vulkan. Remember that we only specified a minimum number of images in the swap chain, so the implementation is allowed to create a swap chain with more. Okay, that's why we'll first query the final number of images with vk get swap chain images, then resize the container, and finally call it again to retrieve the handles. Okay, we've seen this pattern a few times before as well, so let's copy this and then C++erize it. Null our image count you've already got, p app swap chain, p app device, swap chain images dot resize. What is that? Oh, it's also that we don't have this data. Swap chain images, that comes from p app too. But this array of swap chain images, we can't resize it like this because that doesn't work in C. So what do we do? Oh, let's just create a little temporary array of that particular size. So it's called vk image. Let's just call it swap chain images of the image count. So there you go, there's our temporary, there is our array. Excuse me. And then we'll just set that to be equal to that, which is just, I think that works. It's space for our array. Yeah. We create an array of the correct size, assign it to, or assign this to point to it. Now, if we assign to point to it, and then when this function exits, do we still have a reference to it? Or do we need to dereference it? Assignment distort vk image star from incompatible type vk image. I don't know, I don't think so. I wonder if that works. We can test this by, let me just do this when I get rid of that, because let's test it by running it, that would be helpful. Let's finish up first. One last thing, store the format and extent we've chosen for the swap chain images in the as member variables. We'll need them in future chapters. Okay, all that jazz. Okay, swap chain, not all that jazz, just these two. Okay, so I'll come back to this. This struct is getting pretty sizable now, eh? So I've selected format and I've selected extent. Okay, back down to where we're creating them. And then we'll say we'll say swap chain image format equals surface format and p-app swap chain extent equals surface. Wait, no, it's just extent. Extended to. Right, cool. So those are saved. Let's just run it and see if it works. Seems to work. It seems to work totally fine. Can't actually resize it, but that's fine. But I'm really curious whether this is the correct way to do it. And we can test it within our query swap chain function. So when we query the swap chain, we're doing the same pattern where we create a little temporary array, and then we use it again. We assign that to this d.format, and then we update the d.format, and then we return, but we're returning a copy. So perhaps it does all the full copy for us. But we can potentially test some stuff. I don't know. I feel like this might cause a problem, so I'm going to make a little note to say, note, this, I'll put it here, may not work outside of this function scope. Reused by os/c runtime. C runtime might say, hey, this variable is no longer in scope. All these addresses, OS, have that back. I think that could happen anyway. So I'll say, could be solved by doing this, but dereferencing and similarly doing that. Well, let me just try that anyway, see if that actually makes any difference at all. That kills it. So that is a problem. So I guess I was wrong. Excellent. Well, in that case, I think we are done with this chapter. We now have a set of images that can be drawn onto and can be presented to the window. Excellent. The next chapter will begin to cover how we can set up the images as render targets, and then we can start looking at the actual graphics pipeline and drawing commands. Fantastic. That'll be fun. All right, let's commit that, git status, git add main, and git got commit. I did got commit. Created swap chain. Yeah, fully created swap chain. And retrieved swap chain images. I don't need to make those capitals really, do I? Git push origin main. Done and done. Right, next time we shall be looking at graphics pipelines. Excellent. Until then, see ya.